So I've got this L1 and this pi1 plane. Okay, let's check if L1 will lie on pi or not. So first method is, if you want to know this is on pi, again, we visualize. If you have pi, you want to have the line directly on the plane. First check is always, are they parallel? So let's start with A. Check number A. Is L parallel to pi? How to check that? Take the direction of L, I call it M. We try to dot with N, which is a normal vector here. Direction vector is 2 minus 1 minus 1. We do dot product with that 1, 1, 1. Work out the dot product to show that you will get a 0. So therefore, we will say that M is perpendicular to N, which means that L is parallel to pi. And second check, parallel doesn't mean that it lies on the plane. It could be above the plane. So we should take a point from L. I'm going to take 1, 2, 2. This is the point that is on L. Remember, position plus direction. I take this point from L and I substitute into pi. Which means I want to replace this R to be your 1, 2, 2. We work out the dot product, which will give me 5. Importantly, I'm trying to check whether this value matches the one on the right-hand side there as well. Okay, so from this, since it matches, we can conclude. So 1, 2, 2 lies on pi. And the final conclusion from A and B is I could conclude that L lies on pi, since it is parallel and a point is on the plane. This will be the preferred method. This is based on what we have been talking about on the previous page also. But I need to show you the other two methods in case the question forces you to go through a certain direction. So let's see other possible methods. If you want to show directly that a line is on the plane, you could actually substitute the entire line into the R. Okay, this means that for the L equation, I can combine into one vector first and replace to this R. Combining means we write in both vectors into one. This is my L equation. Combine into one vector and I substitute into pi. So we take this vector dot plane's equation, which is 1, 1, 1 for the normal. I'm trying to put into this R, by the way. I want to replace here. And you work out the values, work out the dot product. In this case, you will see that the lambda terms cancel out nicely. We're going to get just 5 technically. All the lambdas will get cancelled out. So this is the right-hand side of the plane's equation. So I can conclude, therefore, L lies on pi. As long as all the lambdas are cancelled out and you get the same constant, it will mean that L is on the plane. Method 3, a little bit more rare. For this, I will need you to visualize a little bit. Let's say we have got a line and a plane equation. This last method is about trying to take, say, 2 points. Suppose I have got A1 and A2. If both points are actually on the plane, then it must mean that the entire line, since it is a straight line, the whole line will be on the plane. But for this method to work, you will need to have 2 points from line L. So what are those 2 points? You could choose one vector first, which is the position vector. So you could take A1, for example, to be 1, 2, 2. 1, 2, 2 is on the line. It's the position vector. Or can I take another position vector such that that point is on the line? You can choose, for example, lambda to be any number you want. I can choose lambda to be 1. So if I choose lambda to be 1, what is this equation now? Will be your, let me simplify, it's 3, 1, and 1. Okay, I change lambda to be 1. And let's substitute both into the plane equation. So for both of them, we substitute 2 pi. You want to know whether these 2 points are on the plane or not. So if I substitute here, we work out the dot product. I get 5. We take 3, 1, 1. It's also 5. So from here, I can conclude these are vectors. So I will say these are position vectors of points from L. And both of them lie on pi. Once you get 2 points from L that is on the plane, you can conclude I conclude that the whole line is on the plane. Okay, but you should know that the main check should be based on the first method. Always try to check for parallel first, then take a point from L to check if it's on the plane. The other 2 methods we should use only if the question forces us to do so.